Hi everyone. So today we have Unit 9, Day 5 notes about radian measure. So you may have seen on your calculator when we talked about trigonometry that we needed to make sure your calculator was in degrees. So there is something also called radians. So radians is another way to measure angle measures. Just like we have different ways to measure length, inches, centimeters, miles, kilometers, things like that, we also can measure angles using a different unit other than degrees. So a radian is defined to be the measure of an angle that is formed from an arc whose length is the same as the radius. So if you look at this picture, I have a circle O and here's my radius R. So it's when your arc length is the same as your radius. So if the radius was 1 inch, your arc length would also be 1 inch. Okay, so going all the way around a circle, there's just over 6 radians. And I can demonstrate that right here in this GeoGebra link. So right here, I have a circle whose radius is 1. Right here, the radius is 1. So as I go around the circle, that is 1 radian. So the blue arc right here is defined to be 1 radian. So as I keep going, it's going to change color now. See that? So that is 2 radians. So we have the blue one, the red one, 2 radians. So now here's 3 radians. 4 radians, 5, 6. So it's just over 6 radians to go all the way around a circle. Okay? Well, if you want to know exactly, it's right about there. It's just over 6. Okay, so we need to learn how to convert from degrees to radians. So on the reference sheet for the Common Core, it is down here. So do you see radians and degrees? 1 radian is 180 degrees divided by pi. The degree goes with 180. Or if you want to change, convert the other way, 1 degree is pi radians over 180 degrees. So, you know, the word degrees goes with 180. And radians goes with the pi. So those are right here. So those are on your reference sheet. You don't need to memorize them. But I'm going to show you how to use them. So on this first page, you know, if you wanted to highlight anything, you know, a radian is a measure of an angle that is formed from an arc whose length is the same as the radius. So there's that. All right, so here we go. If you wanted to convert from degrees to radians, just like we did any conversions back in the volume unit, you take the units you're in and you are going to multiply that by a fraction such that those units are in the denominator. So if you, all you kind of need to know is pi goes with the word radian and 180 degrees. So since we are in degrees, we want to multiply this by pi radians over 180 degrees. So when you do this, when you're multiplying fractions, the units in the numerator, you can put your 90 over 1, the units in the numerator are going to cancel with the units in the denominator. So the degrees are going to cancel out. So what we end up with is so it's really just 90 pi over 180. And the 90 and the 180, well, this now is in radians. We can abbreviate radians by doing rad. So the 90 over the 180 reduces. 90 goes in that twice. So it turns out to be pi over 2 radians. And that's how you leave your answer. You know you're in radians when you have pi. All right, let's try 210 degrees. So again, degrees needs to be in the denominator. And here's my conversion. Pi radians is equivalent to the 180 degrees. So the degrees in the numerator cancels with the degrees in the denominator. So you have 210 pi radians over 180. And just to remind you how to reduce fractions, you could type in 210 divided by 180, and it gives you that decimal. And then you can press the math button and change it back to a fraction. You hit enter, enter. So it's 7 over 6. So it's 7 pi over 6 radians. So it's that easy. It really is. So if you wanted to convert from radians to degrees, you're going to multiply by your 180 degrees over pi radians. So again, this value here, I can rewrite this as pi radians over 9. And since radians is in the numerator, I need radians in the denominator. So my conversion is 180 divided by pi radians. All right, so the radians cancel out. And we also have that the pi's cancel out. So it's now just 180 degrees divided by 9. And it goes in there 20 times, so it's 20 degrees. All right, let's try another one. 7 pi radians divided by 2. So I'm going to move my radians into the numerator, and I need radians in the denominator, so my conversion is 180 degrees is equivalent to pi radians. So again, radians is canceling out, the pi's are canceling out. So multiplying fractions, you have 7 times 180. We're now in degrees, and you're dividing that by 2. So I'm going to go to the calculator. 7 times 180, divide that by 2. So that turns out to be 630 degrees. You are going around a circle more than once, because there's 360 degrees around the circle once. So you're going around more than once. That's what that represents. So this is how you do it. All right, here's some practice for you to try on your own. But I will do this for you. So find the radian measure of the angle of the given degree measure. So again, if you have degrees, you are multiplying by 180 degrees. That has to go on the bottom. And then your pi radians goes in the top. So the degrees cancels out. We're going to have 30 pi over 180 radians. 30 over 180, I know I can reduce that by 10. 3 goes into 18 6 times, so I know that's pi 6 radians. 90 degrees, we are going to multiply. I need degrees on the bottom, oops, not a 2, and then pi radians in the top. I'm already thinking about reducing 90 and 180, and I'm coming up with a 2. All right, so the conversion is pi radians over 180 degrees. The degrees cancel out. So you have 90 pi over 180, and that's going to be now in radians. This reduces to pi halves radians. Again, if you want to see it on the calculator, you're doing 90 divided by 180. It's 0.5, you know, which is the same as your 1/2. Or if you did your math, enter, enter. There's your 1/2. All right, find the degree measure of the given angle of the given radian measure. So I'm in radians. So I'm just going to rewrite this and move the radians in the top. So now I know I need pi radians in the bottom, and that matches up with 180 degrees. The radians cancel, the pi's cancel. So really all I have is 180 degrees divided by 3, and 180 divided by 3 gives you 60 degrees. All right, pi halves radians. So again, I'm going to take radians, write it as rad in the numerator, and then I know I need my radians in the denominator and 180 degrees. In the numerator, that's my conversion. Radians cancels out, the pi's cancel out. So I'm left with is 180 degrees divided by 2, which we should all know is 90 degrees. Okay, so it's really not bad at all. All right, so now I want to review arc length and area of a sector. Find the length of each arc. Round your answer to the nearest tenth. Okay, so if you notice, well, first of all, let me review arc length. Arc length is the formula where we take the measure of the arc, that has to be in degrees, divided by 360 degrees, times, and then its circumference, 2 pi r. The only thing that's on the reference sheet is the 2 pi r. So we need to be in degrees. So if you notice, I am in radians. So first thing we need to do is take my 3 pi halves radians and change that to degrees. So I need my pi radians in the denominator and my 180 degrees in the numerator. The pi and the radians cancel out. So now I have 3 times 180 degrees divided by 2, which should be 270 degrees. So now I'm ready to substitute into my formula. So arc length is now going to be the measure of the arc in degrees. And we want this darker arc here. So that is my 270 degrees divided by 360 degrees. The degrees cancels out, times 2 times pi times my radius. And the only units left are going to be feet. So again, length, you want that to be in feet. So you can put all this over the numerator. So this is all really 270 times 2 times pi times 16 divided by 360. All right, so I've got, this video is kind of dark because I have windows open and it's a bit bright here today. 270 times 2 times pi times 16. I'm going to hit enter. I'm dividing all that by 360, and it did say round to the nearest tenth. So 75.4, and the units left in this problem are feet. That is the length of this darkened arc, 75.4 feet for a 16-foot radius. So it makes sense. This answer should be longer than that. Okay, let's try an area of the sector. Do not round. Okay, that means we're going to leave it in terms of pi. So we want area of this sector here. So let me review. Area is, we need the measure of the arc in degrees divided by 360 degrees times your area formula, which is pi r squared. This needs to be in degrees. We are given radians. So first thing we need to do is take our 19 pi radians over 12 and convert it. So here's my conversions. Radians in the top. I need my pi radians in the bottom, which means 180 degrees goes in the top. The pi and the radians cancel out. So I really have 19 times 180, and now I'm in degrees, and then we're going to divide that by 12. So 19 times 180 is that amount, and now I'm dividing that by 12, which is 285 degrees. Now I'm ready to find the area. So I'm going to go over here and substitute in my 285 degrees. That should look right. This is more than 3/4 the way around. 3/4 the way around is 270 degrees. All right, times pi times my radius, which is 12, and I have to square that, and my only units left are now going to be feet because my degrees cancel out. So if I put that into as a fraction over 1, I'm doing 285 times pi times 12 squared and dividing that by 360, and that will give me my area. All right, so I'm going to the calculator. 285 times pi times 12 squared. I'm just going to hit enter to get that numerator, and now divide the whole thing by 360. Oh, wait, my bad. It said do not round. So we do not want the value of pi in there. 285 times 12 squared, now divide that by 360, is 114 pi, and the units are feet squared. That's my area of this sector. Okay, One last question. Oh, but I'm going to run out of time. I only have 3 seconds left.